Hello dear students, in this video we are going to see the Carnot's theorem, the statement and proof of Carnot's theorem. There are two parts, first part and second part. So the first theorem, statements. The efficiency of a heat engine working between two given temperatures cannot be more than the efficiency of a reversible Carnot engine operating between the same temperature limits. That is, the efficiency of a reversible Carnot engine is maximum. So now we can go to the proof of this theorem. Assume there are two engines. I is the irreversible engine and R is a reversible engine. Both of them are said to operate between the temperatures T1 and T2. T1 is the temperature of the source and T2 is the temperature of the sink. Suppose both of them are doing the same work. Both irreversible as well as reversible engines are doing the same work W. Irreversible heat engine is taking an energy Qi from the source and rejecting an energy Qi minus W because it is doing W work. And a reversible engine is absorbing an energy QR, and after doing work it is rejecting an amount of energy QR minus W. Now we assume that efficiency of the irreversible engine is greater than the efficiency of the reversible engine. That means W divided by Qi must be greater than W divided by QR. So this equation assures that Qi must be less than QR. Qi must be less than QR, or the irreversible engine can be more efficient only if the amount of energy taken by it from the source is less than the amount of energy taken by the second one. Reversible engine from the source is greater. Amount of energy taken by the irreversible engine must be less than the amount of energy taken by the reversible engine from the source. Okay, now we are going to couple these two engines so that they are working between the temperature limits T1 itself. So we are coupling I and R so that I is absorbing heat energy Qi from the source, doing some work W, and it is coupled to R. R is doing the same amount of work and it is rejecting QR amount of energy back to the source. The logic of this theorem, or the proof is, not theorem, the proof is, we are assuming that eta I is greater than eta R, and then we will show that this is not possible, and this method is known as the method of falsification. And if eta I cannot be greater than or equal to eta R, then we can assume that eta I may be less than or equal to eta R. So that is the logic of the proof. So now this is the idea. Here the engines are working between the temperature limits T1 and T2, and it is absorbing an energy Qi. It's doing some work W and rejecting an amount of energy Qi minus W to the reversible engine. Reversible engine is again doing some work and it is rejecting an amount of energy QR. It is working in the reverse way. Reversible engine is working in the reverse way, QR, and here the temperature is equal to T1 itself. We replaced the sink with the source, or at a higher temperature. So reversible engine is working in the reversible way. Then you may ask why this is not connected in the other way, so that irreversible engine is working in the reversible way. It is not possible. Irreversible engine cannot work in the reverse order. It can only work in the forward order. Reversible engine can operate both in the forward order as well as in the reverse order. Now, how much is the amount of energy absorbed from the source? Qi is the amount of energy absorbed from the source. And how much is the amount of energy rejected to the sink? Qr is the amount of energy rejected to the sink. So Q intake by this machine is Qi, and Q rejected, Q rejects is equal to Qr. And what is the total work done? W total is equal to work done by the irreversible engine plus work done by the reversible engine. So therefore this is W plus this is minus W, negative W, because reversible engine is working in the reverse order. So therefore the total work done is equal to 0. Total work done by the system is equal to 0. Now, as we have seen in the previous slides, if the efficiency of irreversible engine is to be greater, Qi must be less than Qr. Now you look at the coupled device. Here Q intake is Qi, that is less than Q rejects, or the above coupled device is working as a self-acting machine which takes some amount of energy from an object or a source at a particular temperature and reject an amount of energy which is greater than absorbed from the source to the same source or to an object which is at the same temperature T1. So it is not possible for a self-acting machine to absorb heat energy from a temperature and reject an amount of energy greater than the amount of energy absorbed to a temperature which is equal or lower than or greater than the actual temperature. So therefore, this violates the second law of thermodynamics. A self-acting machine cannot absorb some amount of energy and reject an amount of energy greater than the amount of energy absorbed to a device or to a system whose temperature is equal to or greater than the temperature of the source from which energy is absorbed. So this violates the second law of thermodynamics. Therefore, we can say this is not possible. Q intake cannot be less than Q rejects, or Qi is greater than Qr. Qi is greater than Qr. Therefore, eta I. So efficiency of the reversible engine is more, or efficiency of the irreversible engine is less than the efficiency of the reversible engine. Okay, this is the proof of the first part. Now we'll go to the second part, second theorem. Efficiency of all reversible engines operating between the same temperature limits are equal to the efficiency of reversible Carnot engine. So our argument is exactly the same. We assume that there are two reversible engines, R1 and R2, both of them are reversible engines. And we adjusted the working substances in both the engines so that they are doing the same amount of work. This is also doing the same amount of work. This is absorbing an amount of energy Q1, or we can say as Q1, and rejecting an amount of energy Q1 minus W. This is taking an amount of energy Q1 dash, and it is rejecting an amount of energy Q1 dash minus W. Now we assume that the efficiency of R1 is greater than the efficiency of R2. Here also we are doing the same method for the proof. It is a falsification method. We are assuming that the efficiency of R1 is greater, and finally we show that it is not possible. Eta R1 is greater than eta R2. This is an assumption. If this is to be true, W divided by Q1 must be greater than W divided by Q2, because efficiency is work done divided by amount of energy absorbed. Sorry, it is Q1 dash. W by Q1 is greater than W by Q1 dash. So obviously Q1 must be less than Q1 dash. Q1 must be less than Q1 dash. Okay, here one thing is to be referred. Both of them are reversible, and the efficiency is different because of the nature of the working substances. R1 is having a particular working substance, R2 is having a different working substance, and we say that the efficiency of R1 is greater because of the nature of its working substance. Or this theorem mainly says that the efficiency of reversible engine is independent of the working substance. Okay, Q1 dash, Q1 is less than Q1 dash. Now we will do the same thing. We will couple these two devices between the same temperature limits. T1 is the source, and this is our R1, and this is our R2, and this temperature is T1 itself. This is doing a work W, and this is also doing the same work W. Here the amount of energy absorbed is Q1, and here the amount of energy rejected is Q1 dash. So here both can be operated in the reversible way, but we are operating R2 in the reversible way. R1 is absorbing amount of energy Q1 from the source T1. So amount of energy intake by this coupled machine, intake is equal to Qi, and amount of energy rejection, amount of energy rejected, that is equal to Q1 dash. W total work done, that is equal to W1 plus W2, total work done. So it is W plus minus W because R2 is working in the reversible way. So there is no external work done. And now you look at the situation here. From a source of temperature T1, the system is absorbing an amount of energy Q1, amount of intake is Q1, and it is doing some operations. We cannot say that there is some work, there is no work at all. Doing some operations, a cycle of operations, and rejecting an amount of energy Q1 dash to an object at the same temperature. And the amount of energy rejected here is greater than the amount of energy absorbed. That is not possible. It violates the second law of thermodynamics because no engine, unassisted by an external agency, cannot transfer heat energy from an object at a temperature to an object at the same temperature or at a temperature greater than that. So if this is working in the same way as we described, it will behave like a self-acting machine which transfers heat energy from a temperature T1 to the same temperature T1 without the assistance of any external agency. So this is not possible. This violates the second law of thermodynamics. So therefore we can say at the maximum Q1 shall be only equal to Q1 dash. Q1 shall be only equal to Q1 dash, or at the maximum we can say eta 1 or eta R1 is equal to eta R2, or that is meant to say that the efficiency of a Carnot engine is independent of the gas that is filled inside the engine as the working substance. So these are the two theorems, and you just go through the theorem again, proof also again and again. This is more of a philosophical theorem, and it has many applications in thermodynamics as well as in philosophy. Okay, thank you very much.